Hello friends, this question is from the subjects of analog. Topic name is BJT and JFET frequency response. In the problem we have given one NPN transistor and it is been told that you can the CV is effectively short circuit in the mid signal frequency response, and C is basically finite, and it is also given that the lower cutoff frequency of the circuit is 100 Hertz. Okay, so we need to find out the value of C. So for that, such that we lower cutoff frequency of the circuit will be 100 Hertz. So we know that the C is as you can see that C is connected in the emitter circuit. Basically we need to find out the cutoff frequency corresponding to emitter bypass terminal. So for that we know that the cutoff frequency of any terminal is basically equal to the 1 upon R equivalent of that terminal into the C. So we need to find out the R equivalent of the circuit across the terminal. So first thing is that we need to find the R equivalent of the circuit, because once we can find out the R equivalent of the circuit, then we can just as multiply with the C, and this will be my frequency, which we know. We know this value 2 pi f. So f is given to us, so we already know this value. If I can find out this R equivalent, then with the help of these two values I can easily evaluate my C. First of all, I need to find the R equivalent. So for that, draw the small signal model of the circuit. So the small signal model of the circuit will be Rs times R pi is given. So basically, I am going to draw the R pi model at at low frequencies. R pi into R pi model, or it also known as a conductance model, because it has a GM, VB, and now we have a RE, which is parallel with capacitor CE, right? And across GMVB in the collector terminal we have another resistor. This resistor has a value of RL, so it will be RL, and from base to collector we have voltage drop VBE. So this is my base voltage, this collector terminal, it is my emitter terminal, and my input voltage is shorted. Input terminal is shorted because I want to find the R equivalent of the circuit, so that's why I want to short the supply voltage, because I want to find the R equivalent of the other terminal. Basically, I need to find the R equivalent across this terminal, right? So it's a standard method of finding R equivalent across this. This circuit is similar to the output. The circuit is very similar to the output impedance of the common collector. The circuit the output impedance circuit of the common collector is also similar to this network only. We need to find that on like that only. Let's assume we have one supply of voltage V, because we are calculating output impedance. So we have short circuit the input voltage, and I'm assuming a voltage at known voltage V with a current I. So this terminal voltage will be V. Okay, this ignore this CE, because we are not considering CE here. Why? Because we are trying to find the R equivalent. Whatever value of R equivalent we can get, we just multiply that value with our CE. Okay, that's why we are ignoring CE here. So now let's apply the nodal analysis at node V. Apply nodal at V. So you can see that this IV is incoming current here, this node. Here GMVB is incoming current, and in this terminal RE, current is outgoing. So my total incoming currents are I plus IB plus GM VBE, and outgoing current is V by RE, current across RE path. Okay, I have assumed one finite voltage source of voltage V and current I. Okay, current I. Now the value of IB will be, IB is the path current of this loop, input loop. So I can represent IB as 0 minus V upon RS plus R pi. plus gm. We know that from the expression gm is basically what? Gm is basically equal to the gm is related to the beta, as gm is what? Beta r pi, right? So we know that beta is given to us, which is okay, beta is unknown to us. Gm is already given to us, zero point 0.1 mho. Okay, then it's fine. Okay, so then gm and vb is what? Voltage drop across r pi, which is ib into r pi, which is ib into r pi. Okay, for v by re. So if you're going to solve this expression and find out the expression in terms of v and I, then you can get the expression by solving. Put the value of ib here also, the same expression. So by calculation, after the calculation of this expression, you will get the final expression as re plus re into rs plus r pi upon rs plus r pi plus re plus gm r pi re. Right, this will be your final expression for this calculation. If you want to, if you represent the gm with terms of if you wish, you can represent the gm with beta re. You can replace the gm with beta re, and if you're going to do that, sorry, gm is not beta re, beta is gm r pi. Okay, so my gm will be beta by r pi. So if you want, if you can replace the gm with beta by r pi, then you will get the expression as re parallel rs plus r pi upon beta plus 1. That will be your r equivalent. So let's put the value of re, rs, r pi and beta plus 1. If you can put the value of all these variable, then you will get the r equivalent as 26.8 ohms. Right, and you will get the r equivalent at 26.8 ohms. Now you have get the r equivalent, which is 26.8 ohms. You need to find the CE, which is equal to, and then this combination is equal to the cutoff frequency, which is 2 pi into 100. So your CE will be equal to the 1 upon 26.8 into 2 into 3.14 into 100. So basically your CE will be equal to the 59.4 microfarad. So I calculated your CE value is 59.4 microfarad, which is option number D. So you can see that, so this kind of questions are very important in terms of gate point of view. What you need to do whenever the question asks you to calculate the cutoff frequency of particular terminal, find out the R equivalent corresponding to that terminal. Okay, so draw the small signal analysis. Like in this case, okay, it is we have to find the equation impedance in the output terminal, right? So we have short circuit the input voltage, and we have calculated the impedance by assuming another voltage source with voltage V and current I, and we have find out the V by I, which is nothing but my R equivalent. Okay, so this is the standard method. This kind of questions are very important in gate point of view, especially in the common data and linked data. Thank you very much.